Hi everybody, this is Eric White. In this screencast, I'm going to show you how you can very precisely calculate the sizes of cells in OpenXML Spreadsheet ML. I'm going to show you how you can calculate the width of columns very precisely and how you can calculate the height of rows very precisely. And of course, from that information, you can know the exact size of each cell in a worksheet. There are two reasons why we want to know the exact size of each cell. The first is for precise positioning of images on a worksheet, and the second is for precise positioning of controls such as buttons, checkboxes, or drop-down list boxes. Once we have the exact size of every single cell in a worksheet, we can position those things very exactly. First thing I'm going to do is create a blank Excel workbook. I'll call it test.xlsx. Let's open it, and I'm going to put a little bit of data in there. And next I'm going to resize this first column and make it somewhat smaller. Save it and close it. Now I'll drag this workbook onto Visual Studio. I'm using the Visual Studio OpenXML Package Editor Power Tool for Visual Studio 2010. Let's take a look at Sheet 1, which was the sheet we just modified. Here's the data in the sheet. And up above the data, we can see that there is this calls element, and in there is a single call element. And this call element tells us that starting at column 1 and ending at column 1, the width is 3.855. We'll talk about what the unit of measure is for this width attribute here in just a second. The form of this call element is such that if there are multiple columns adjacent to each other that have the same width, there is only one call element for those adjacent columns. Let me show you what I mean by that. I'll reopen our workbook and worksheet. I'm going to select 3 columns here, and I'll make them somewhat narrower. Not as narrow as column A, but more narrow than the rest of the columns. I'll save it and close it. Now I'll come back over here to Visual Studio, and Visual Studio will tell me that this file has changed outside the editor. Do I wish to reload it? And I do. And I'll reformat the XML. And here, as you would expect, now there are 2 call elements. The first one indicates that there is a custom width for column A, and the second call element indicates that there is a custom width for columns B, C, and D, in other words, columns 2, 3, and 4. Now let's make another change to that workbook. Let's select the entire worksheet. I'm going to resize one of the columns, and as you know, if you select the entire worksheet and resize one of the columns, all of the columns in that worksheet are now set to that width. Save it and close it, and go back to Visual Studio and reload, reformat. And now what we can see is that there is no longer a calls and call element. Instead, Excel set this default column width attribute on the sheet format properties element. This indicates that all columns in this worksheet are set to 8.85. So the question is, what is the unit of measure of this 8.85? Let's go to the OpenXML standard, and we're going to look at section 18.3.1.13. Here we are. I'm going to scroll down to that width attribute. Here is that width attribute. And the definition of this unit of measure is that it's the column width measured as the number of characters of the maximum digit width of the numbers 0 through 9 as rendered in the normal styles font. To put it in simple terms, What this really is, it's the number of digits that you can show in a column in the normal styles font. The definition also tells us that there are 4 pixels of margin padding, 2 on each side, plus 1 pixel for the grid lines. One key point about this is that the normal styles font is important. The normal style is a special style that affects the sizing of column widths and row heights. For those of you who are familiar with typography, you know that in just about all fonts, regardless of whether they are fixed width fonts or variable width fonts, the widths of the digits are always the same. In other words, the width of a digit 1 is the same as the width of a digit 8. And the reason is that regardless of whether you are using a proportional font or a fixed font, if you have columns of numbers, you want all of those numbers to line up appropriately. Once we know the width of a digit in the normal styles font, then we can find the exact calculation of the pixel width of the column here. This width here is that character width that we saw in the markup, and this maximum digit width, which we see here, and we also see it here. This is the maximum digit width that we have to calculate based on the font of the normal style. Let's go and play with that workbook and worksheet again, just to show you that in fact the font for the normal style has an impact on the sizing of things in that worksheet. I'll open up the worksheet. I'll right-click on the normal style. I'll indicate that I want to modify that style. I'll click the Format button so that I can change the font. And just to keep things simple, I'm going to change the font size to 16. I'll click OK and click OK. And here we can see that both the column widths and the row heights have changed. This shows that the font for the normal style is actually a special font. It has impact on the sizes of things. Let's change it back to 11 for right now. It's a little easier to look at. So in calculating these sizes, the first thing that we have to do is determine what the font is for the normal style. To find out what the font is for the normal style, I'm going to open the styles part, the styles.xml part. And down here at the bottom, we can see in this cell styles element, there is a cell style element with the name of normal. We can see that it uses an XF ID of 0. That XF ID of 0, that's a pointer into this cell XFS element. The XF ID attribute in the cell style element matches up to the XFID attribute in the XF element. So that means that this XFID indicates that this XF element is the element of interest to us. And in this XF element, it tells us that the font ID is 0, and that is a 0-based index into this fonts element up here. That indicates that it's this font element here that contains the font for the normal style. Let me change it and then we can see that change. I'll open the workbook. I'll modify the normal style. I'll format it. I'll change the font. I'll change it to Consolis and I'll change it to 14 point. And click OK and click OK. Save, close. Come back over to Visual Studio. It tells us that I should reopen the spreadsheet. And here we can see that in fact this font element has changed to the family of Consolis and a size of 14. Once again, I'm going to change it back to Calibri 11 just because that is the most common font family and size that you're going to find inside of a workbook and worksheet. Now we can look at some code. Here is a method to get the normal font information from a workbook. First thing it does is it opens up the styles part. It finds that cell style element that has the name attribute set to normal. Once it finds that element, it then gets the XFID from that cell style element. And once it has that XFID, it then gets the XF element from the cell XFS element. Once it has that XF element, it then gets the font ID from that XF element. It then looks up the font element from that font ID element, and it can retrieve the family name and the font size. Now we're ready to look at the method to get the column width in pixels. This method takes a maximum column. In other words, if you are interested only in columns 1 through 20, you can pass a 20 to this method, and this method will return an array of column widths for columns 1 through 20. The first thing that this method does is to get the family name and the font size using the method that we just looked at. Once it has the family name and the font size, it then can create a new font object. And of course, that font size is specified in terms of points. So when the code creates a new font object, it specifies that the unit of measure is point. Now, the next thing that this code does is an interesting little technique that you have to do in .NET if you want to get font metrics. And that is somehow or other you have to get a graphics context. The easiest way to get a graphics context is to create a new bitmap and then get the graphics context from that bitmap. Once it has that graphics object, it can call measure string. It passes in a string with the single character of 0. It passes in the font that we just created, and it retrieves a size F object. We can get the width out of that size F object. Once we've retrieved that digit width, we're free to dispose that graphics object. We don't need it anymore. In that worksheet, the data is stored in those calls and call elements. That's not the most convenient form to work with them. What we really want is we want a list of floats with the column width for each one of the columns starting at 1 and going through the maximum column. And that's what this little projection does here. First thing that it does is to look in the calls and call elements and see if the column that is of interest is in that calls and call elements. If it is, it can just return the width of the column based on that information. If the column isn't in that calls element, then the next thing that this code does is it looks for the default column width in the sheet format properties element. If it finds the default column width in that sheet format PR element, then it returns it. And if it doesn't, then the width of the column, in other words, the width of any column that is not defined in those calls and call elements, and if the default column width is not defined, then the column width is 8, and this calculation here from the specification calculates the character width for a column of 8. Once we have calculated the column widths in that character value for every one of the columns of interest, then it's a simple matter to perform the calculation here, which is the calculation that I pointed out in the specification to calculate the width in pixels for each one of those columns. So let's go in here and I'll make column A very narrow. I'll change columns B, C, and D to be somewhat more narrow. And I'll make column E to be quite a bit wider. I'll save this workbook and worksheet and close it. So let's run the example. Here we can see that column 1 is 30 pixels wide, columns 2, 3, and 4 are 46 pixels wide, column 5 is 138 pixels wide. And let's go take a look at that and see if that jives with what is actually in that workbook and worksheet. So I'll start up a trusty little tool that is going to let me come in here and select the exact width of that first column. And you can see that in fact that column is 30 pixels wide. And let's look at the width of column B. And you can see that the width of column B is in fact 46 pixels wide. Now let's talk about row heights. I'm going to go into this workbook and worksheet and I'm going to change the height of row 2 to be much smaller. I'll save it and close it. And let's go back to Visual Studio and reload the workbook and worksheet. Format the XML. And if we drop down here, we can see that in fact row 2 does have a custom height and its custom height is 7.5. So let's see what the unit of measure is for this HT attribute of the row element. Here's the row element. I'll scroll down here and here is the HT attribute, and the HT attribute is row height measured in point size. And if we drop down to section 18.4.11, we can see that point sizes are 1/72 of an inch. One more point about conversion of point sizes to pixels is that for the purposes of sizes in OpenXML, the DPI is 96. In other words, there are 96 dots per inch regardless of the actual resolution of your screen. So this means that 72 points is equal to 96 pixels. After that, it's a simple calculation. Let's go look at that code. Here is the code to get the row height in pixels. The code first determines if there is a default row height. It then looks through every row looking for if that row has an attribute of custom height or if that row has an attribute of thick bot or thick top. Those are relevant. If thick bottom or thick top are set for a row, that means that the border on the row is a little bit thicker and it changes the calculation. The size of the row is still set properly in that HT attribute, but we have to know whether there are thick top or thick bottom borders so that we know to look into that HT attribute to determine the height of the row. Once the code has determined the row height for any rows for which there is an exceptional row height or a custom row height, it then is straightforward to create an array of integers with the row height in pixels for every row that we're interested in. Taking the row height in points, multiplying by 20, and dividing by 15 is exactly the same thing as multiplying by 96 and dividing by 72. And that returns the exact row height in pixels. And so now if we run the example, we can see all of our column widths up here in pixels, and down here we can see all of our row heights in pixels. Once we have all of these numbers, it then is a simple matter to determine the exact pixel size of any single cell. In the next screencast, I'm going to show you how, given this information, you can position any image exactly where you want to position it on a worksheet. That's all I'm going to cover in this video. Thanks for watching.